Let's evaluate some interesting limits in this video. Let's say we have the limit as x goes to infinity of 1 over x. So we're not going to graph this. We want to just think about this without graphing it. So let's first think about what this is asking. It's saying what happens to the function 1 over x as x goes to infinity. And what happens to the function just means what happens to the y value of the function, right? Because if we have some x input for a function, and then we get some y output. So we're looking for what happens to the y output as x goes to infinity. All right, well, let's see what happens. So we can't really plug in infinity, right? That doesn't really, I'm not sure how to do that. It doesn't really exist. So, but what we could do is find a pattern of what happens as we plug in very large numbers. So I'm gonna plug in 1,000. So first let's plug in 1,000. So 1,000 is pretty large, right? So 1 over 1,000. Well, what happens to this? Well, 1 over 1,000, let's see, that's 0.00001. Okay, let's plug in some larger number. Let's see, let's plug in 1 million. 1 million. Okay, this is equal to, let's see, 0.0000001. I believe that's a million. Okay, and then so we notice that this is smaller than this, right? And as we plug in bigger and bigger and bigger values for x, right? As we get closer to, whatever closer to infinity means, as we plug in larger and larger numbers, it seems like it's just approaching 0. And that's exactly what this answer is. The answer is just 0, because the limit as x goes to infinity of 1 over x is 0. And then what that means is it approaches 0 as we go to infinity for x. So we did some experiment. We conducted some experiments with x values. We plugged in large x values. We started with 1,000. We went to 1 million. We could have done a couple more. And we noticed that it's just approaching 0. So the answer to this question would just be 0. And you could just graph that and also look at what happens as x goes to infinity. All right, let's do a similar problem, but this time we're going to do a different limit. So we're going to say the limit as x goes to 0 from the right of 1 over x. So this is important. We're going to 0 from the right side. So from the right side. So that's important. And if you don't really understand this notation, I encourage you to watch the video where I introduce this notation. Okay, so again, what we're gonna do here, we don't really have much. We don't have much to do here unless we graph it, or we can plug in some values, right? So let's plug in some values close to 0. And we have to remember that it's from the right. That means close to 0, but positive. So I'm going to plug in 0.1, right? That's close to 0, but from the right. Well, 1 over 0.1, that's 10. And you can quickly figure that out by multiplying the top and bottom by 10, noticing that the bottom becomes 1, the top becomes 10. 10 over 1 is just 10. So that's 10. Okay, let's plug in some smaller values closer to 0. So limit as x. And I shouldn't really say equal to, right? I'm going to put a little squiggly line, because that's not the actual answer, right? We're just experimenting still. So let's see. Limit as x goes to 0 from the right side of 1 over x and be squiggly equal to 1 over 0.01. Okay, notice how we're closer to 0 now from the right. Well, let's see what that is. So 1 over 0.01, you can either plug that into your calculator or multiply top and bottom by 100. Notice that we get 100. All right, let's do one more. Limit as x goes to 0 from the right of 1 over x is 1 over 0.001. This is 1,000. And notice how the pattern here is that this is just getting bigger and bigger. 10 to 100 to 1,000. So it looks like it's approaching a very large number. So we can say that the answer for the limit as x goes to 0 from the right of 1 over x is equal to infinity. So this is not, we can only say something's equal to infinity when we're doing limits, right? It doesn't really make sense to say the answer is infinity, but it does make sense to say that it approaches infinity. And that's what we're saying when we discuss limits. So the answer to limit as x goes to 0 from the right of 1 over x is equal to infinity. Again, I encourage you guys to graph this and see how this reacts, this function reacts as we approach the 0. Keyword from the right. Now let's do the same function with a different limit that is very similar. Now we're approaching 0 from the left. So a little negative sign there, from the left. Again, of 1 over x. Alright, let's do some experimenting here. So now we want to plug in numbers that are really close to 0 but are from the left, so they're going to be negative. First one I'm going to try, let me change the color, I'm getting tired of that color. First one I'm going to try is 1 over negative 0.1. Right? Similar to what we did on the previous example, but it was positive because it was from the right. Well, this is negative 10. 1 over negative 0.01. Well, that's negative 100. 1 over negative 0.001. That is negative 1,000. Notice again how we're reaching negative infinity in this case, right? Really, either, you can say large or small. In this case, large negative values, right? So negative infinity would be the answer to this. And there's an important thing to understand here, that when we reached the 0 from the left side, we reached negative infinity, which is, you can think of it as exact opposite of infinity, right? So the answer for this is negative infinity, but the answer for limit as x goes to 0 from the right of 1 over x is infinity. And for that reason, the limit as x goes to 0 of 1 over x does not exist. And let me tell you why it doesn't exist. You might know why, but the reason for it is from the left it reaches negative infinity, from the right it reaches infinity, and so for that reason the limit as x goes to 0 from both the left and right doesn't exist, because it's different for both. And that's a very interesting thing that you should think about.